16.2, but it is just a continuation of Module 4. So we are still talking about rates of change, but we're going to introduce a new word called slope. And so today as I can find a rate of change, which we've done, but also or the slope. So if you notice our key terms, the rate of change is that ratio of amount of change in the y variable. Remember, the y was that second variable in the table to the amount of change in the x variable. And if you notice, slope is exactly the same ratio, just talked about a little bit differently. So a slope is a ratio of the amount of change in the y, which we now call the rise because it's the up-down of a coordinate plane or graph, to the amount of change in the x values, or the run, because it's the left and right. And so notice it's the same, it's just the y compared to the x's. Take a moment, pause, make sure you get those copied down. So we are going to look at this in tables, but also in graphs today. So Eve keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or variable. So we talked about this last week. Constant is the same thing over and over, but now we just have a term for when it's not the same thing. It's called variable. And so we would do 15 over 1 and get 15, and then 45 over 3 and get 15, and then 90 over 6, right, that's 1, 3 left over, 15, and then 120 over 8, my pen doesn't want to write, all right, that's 1, 12 to 8 is 4, so then that's 15. So we would say this is constant because everything is the same. If these were not the same, we would call it variable. So this rate right here, this is a rate of change, but we can also call it the slope because it is how much the line, if we graph it, would slope, right? That's what we would say. So if you notice, it's always the rise, the y over the x's still. So rise, we always do up, down, and then left to right. Okay, and right, you have to get up before you can run. So we rise before we run. So when we're looking at a graph, the way we can find that is we can start at one of the points and count how much I need to go up to be level with my other point. So they went up 2. And then we would count how much I have to go left or right to get to the other point. So we went 3, but the reason it's -3 is because we went to the left. And so we would call this a slope of -2/3. Okay, now we can go either direction. I actually could start from this point and do the same thing, 1, 2. That would just be -2. And I could go 1, 2, 3 and be +3. But notice -2 over 3, the other way is the same. Okay, so we're making these perfect right triangles when we're trying to find the slope. Okay. Okay, so here is one. I want you to see if you could do this one and see if you find out if it is variable or constant. So again, we would check out those ratios. So change of y to x. So that is one little difference. So you do these ratios, but we also could find the change, right? Change meaning how much does it move. So another way we can do this is I can see how far away is this one from this one. It's 18. And this one to this one is 1/2. And then I can check this change. So 831 take away 18. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's 13. And that's also 1/2. Well, that's already a problem, right? They changed the same here, but different here. So if we check here, 31, take away 26, 11 is 5. But also, if you look at this, I actually went down, so this is actually -5 and then a half. So the x's are changing by the same amount, but the y's are not. And because the y's are not, that's a little off, right? Something's not right. And then also, if we even compare it the other way, right? 0 over 0 is 0, and 18 over a half, if we actually reduce that, it'd be 36. Well, we're a problem, right? And then 31 over 1.5. If we reduced that and found out how many times 31, well, that's 20.6. So we also see that didn't work either. So we would say that this is variable. Ooh, that was a horrible circle. Not sure what happened there. So we're going to use a slope formula to find the slope between 2 points. Okay, so that was that subtracting I did. Remember, I took my y, we'll call it y1, and we subtracted y2. That was the second y. And then I took x1 and I subtracted x2. Okay, so that's the slope formula. That's going to give me slope. That's change, right? And then when the rates of change of a variable is constant, it creates a straight line. Same slope between any 2 points on a line. So that's us finding the change, as I'm just subtracting. And that's what I did on that table. If you want to go back and look, I was subtracting some y's with some x's. Okay, so I want you to see if you can use the rise and run like I did with the triangles on the second example, and see if you can find the rise, the up, down, and the run, the left to right, and then write it as a ratio for the slope. And we'll talk about it when we get back. Until next time.